Hello again, this is Mr. Knox with Mrs. Kim and Mrs. Early. And as always, you guys should have already read Chapter 2, Section 3 in the book, which is on pages 52 through 60. This is about reflection and refraction. After this video, you guys should know the law of reflection, you guys should know how light interacts with different mirrors, and how light interacts with different lenses. So, the first thing you guys need to know is light reflects off all surfaces except for black. As you guys know, black absorbs all color, but it reflects off of all surfaces. Even my shirt, light reflects off of it. In fact, blue light is reflecting off of it. Now, there's two types of reflection, clear versus diffuse reflection. What we're going to really focus on is the clear reflection. Clear reflection occurs when you have a mirror or a still piece of a still pond or a shiny piece of glass. It's where it's nice and smooth, where you have a nice smooth surface. And as light comes down and hits this smooth surface, it's going to bounce off uniformly. If you think of reflection like a ball, you guys are correct. So if you bounce a ball at this angle on a smooth surface, you know you can predict where the ball is going to bounce. Bounce the ball here, it's going to bounce nice and uniformly. However, if you have a very bumpy surface like my shirt or my skin, it's awful bumpy. And when a light hits a bumpy surface, the light's going to bounce erratically. Sometimes the light will bounce this way, that direction. It'll bounce in any direction, and you will not get a reflection. On clear reflection, you will see yourself. On diffuse reflection, you will not see a reflection, but light still reflects. So this gets us into the law of reflection. The law of reflection simply states the angle of incidence equals the angle of reflection, which means the light coming in is going to be leaving at the same angle that it hits. So these two angles right here are the same. Whether it be 30 degrees, this would be 30 degrees. That is the law of reflection. Now, law of reflection for a mirror is this. You have the incident ray and you have the reflected ray. So if you were standing right here in the room and we had a big mirror and you could see somebody's eyes standing over here, they could see yours because of the law of reflection. They are standing at the same angle that you are. So the law of reflection is the angle of incidence equals the angle of reflection. Some examples of the law of reflection are, we have a periscope. A periscope uses a couple mirrors in order to see up higher, as well as a car headlamp. And you can see as the light shines, the light hits this mirror and bounces off. So this angle right here would be the same angle as this right here. So the big thing is reflection. If you think of a ball bouncing, that is reflection.
Alright, so we use mirrors to help us see in different ways. An example is a periscope. So submarines under the water can see above the surface. Oh, we already did that one. Concave mirror. Something we haven't done yet. So what is this point right here called? Well, it is called the focal point. A concave mirror curves inwards, as you can see here, the surface curves inwards. And the focal point is the point at which rays parallel to the optical axis meet or converge. So rays are reflected to the optical axis back through the focal point. A convex mirror, the surface curves outwards. This time, however, the focal point is behind the mirror. So we're still reflecting parallel rays of light, but the difference is the image that is produced. So in a convex mirror, we're not creating a real image. It is a virtual, smaller image. So if you've ever noticed on the mirrors on the driver and passenger side of your mom or dad's car, it may say, if you look real closely, objects in the mirror are closer than they appear. And because those car side mirrors are a convex mirror, it makes the image seem further and smaller. The advantage to this type of mirror is you can see a larger area.
Okay, so we just heard that mirrors reflect light, makes it bounce off and go in another direction. Lenses let light go through, but it makes it bend as it comes out the other end. And that is because lenses are curved. And so light doesn't just go in and then come out exactly the same. It's either going to come together or go apart. There are two different types of lenses, convex and concave. You can see from here that convex lenses are thicker in the center and thinner at the edges. This makes light rays change their speed up here, and so it makes them come together. And you remember from learning about the eye that this is the focal point, and so you actually have convex lenses in your eye. Now, in order for you to see perfectly, people with perfect vision, the focal point comes together right on the retina. Another example of convex lenses are magnifying lenses. Have you ever tried to burn an ant using a magnifying lens? Well, you could do that. I hope you didn't, but if you did, that was because the light rays came together and that's where the ant was, and it intensified and made the light rays come together. The other type of lens is a concave lens, and as you can see, it's thinner in the middle and thicker at the edges. So light will go in, and you will see that the bottom part of the light ray is going to come out of the lens faster than the top, and then it's going to make it change direction. It makes the light rays spread apart or diverge. And people with nearsightedness, people who can't see far away, they use this type of lenses because their eyeballs are too long and the focal point doesn't come right on the retina. So they need to use this type of lens to make the light rays spread out a little bit so that it will reach the retina. So what do we call the bending of light? Refraction. So do this with me. Convex, concave. Convex, concave. See how it caves in? Wax on, wax off. Bye-bye.
All right, as you noticed, there weren't too many words in this PowerPoint, but you guys should have listened carefully and taken notes off of our lecture. Thank you.